December 7, 1944. A Wehrmacht artillery officer named Hauptmann Friedrich Weber stood in the frozen command bunker of Battery Wolf, 4 miles east of the Rhine River near Düsseldorf, studying intelligence reports that made no sense. American artillery fire had just destroyed 3 of his carefully camouflaged gun positions from a distance the reports claimed was impossible. 23 kilometers, over 14 miles. His 15-centimeter Schwer Feldhaubitze 18 howitzers had a maximum effective range of 13 kilometers. The Americans were hitting his guns from positions his own artillery couldn't even reach. Weber checked the calculations again, assuming the reports contained errors. They didn't. Somewhere beyond the western horizon, American gunners were methodically obliterating German fortifications with a precision and range that violated everything Weber had learned at the artillery school in Jüterbog. The Wehrmacht had spent 5 years of war believing they understood the limits of field artillery. They were about to discover how catastrophically wrong they'd been. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The weapon destroying Weber's battery was the 155mm gun M1, nicknamed Long Tom, by American soldiers who'd grown accustomed to its thunderous bark and remarkable reach, but calling it merely a gun misses the point entirely. The Long Tom represented a fundamental reimagining of what heavy field artillery could accomplish, and German commanders in late 1944 were paying for their failure to anticipate it with the systematic destruction of defensive positions they'd considered invulnerable. The story begins not in the fires of World War II but in the mud of World War I, where American forces arrived in France in 1917, woefully unprepared for modern warfare. The United States Army possessed exactly 0 heavy artillery pieces capable of supporting offensive operations against fortified German positions. American gunners went into combat using French weapons, including the exceptional Canon de 155mm Grande Puissance Filou, a long-range gun that could hurl a 95-pound shell over 17,000 yards. French artillerymen called it simply the GPF. American doughboys firing these guns against German trenches called them lifesavers. After the armistice in 1918, General John Pershing ordered dozens of GPF guns shipped back to the United States with explicit instructions. Study these. Build something better. The Westerwelt Board convened in May 1919 to assess artillery performance during the war and chart future development. Their recommendations regarding heavy field artillery were precise and demanding. The next American heavy gun should achieve a maximum range of 23,000 meters, approximately 14 miles. It should elevate from 0 to 65 degrees. The projectile should not exceed 45 kilograms, maintaining manageable weight for crew handling. Most importantly, it should mount on a carriage capable of either tracked or wheeled mobility for rapid deployment. These specifications weren't suggestions. They were requirements born from watching hundreds of thousands of men die because artillery couldn't reach far enough or redeploy fast enough when breakthrough moments demanded fire support. Then came the problem that would plague American artillery development for 2 decades. Money, or rather, the complete absence of it. Congress slashed military budgets throughout the 1920s and 30s, leaving artillery development to stumble forward on funding that wouldn't have built a modern factory, let alone revolutionize heavy weapons. Engineers at various arsenals produced prototype after prototype. The T3 gun in 1926. The T4 gun in 1929. Each iteration improved on the last, incorporating lessons from the French GPF, while pushing toward the Westerwelt Board's ambitious specifications. But without adequate funding for testing, refinement, and production tooling, the prototypes remained exactly that. Interesting mechanical exercises gathering dust in design bureaus. By 1938, as Nazi Germany's Wehrmacht rolled through the Sudetenland and Europe teetered toward another catastrophic war, American artillery still relied primarily on French guns purchased 20 years earlier. The T4 prototype gun, mounted on the T2 prototype carriage, had been sitting in testing for nearly a decade. On paper, it met every specification the Westerwelt Board had demanded. In reality, It existed in quantities of exactly 1. The Army finally standardized the design as the 155mm gun M1 on carriage M1 in October 1938, not because testing was complete, but because war was obviously coming, and the alternative was entering combat with museum pieces. Production orders went to 3 facilities: Watertown Arsenal in Massachusetts, Rock Island Arsenal in Illinois, and Watervliet Arsenal in New York. The initial contract called for 20 guns. 20. For context, Germany had already manufactured thousands of artillery pieces by this point. The United States was approaching global war with a heavy gun inventory that wouldn't have equipped a single division. The M1 gun itself measured over 6 meters long, fired separate loading bagged charge ammunition, and weighed 31,000 pounds in firing position. The split-trail carriage mounted on 8 double-tired wheels provided the stability necessary for sustained fire at maximum range. Moving it required either a Mach No 7.5-ton truck or, after 1943, the tracked M4 high-speed tractor, a purpose-built artillery prime mover that could tow the Long Tom at 33 miles per hour across terrain that would bog down wheeled vehicles. The projectiles themselves were engineering marvels of destruction. The standard M101 high-explosive shell weighed 95 pounds and contained 15 pounds of TNT. Upon impact, it created a crater 6 feet wide and 3 feet deep. The blast radius exceeded 50 meters, meaning anything within a 150-foot circle of the impact point faced potential obliteration. The M112 armor-piercing ballistic capped round could penetrate 6 inches of armor plate at 1,000 yards, or punch through 55 inches of reinforced concrete at 2 miles. These weren't artillery shells designed to harass enemy positions. They were bunker killers, fortification destroyers, weapons built to annihilate structures that conventional artillery couldn't touch. Range defined the Long Tom's revolutionary capability. Standard propellant charges pushed projectiles to 14 miles, 23,000 meters, farther than any other towed artillery piece in the American arsenal. But the Long Tom offered something German artillery officers never encountered in their own weapons: supercharge ammunition. By loading additional propellant increments, crews could extend the range beyond 25,000 meters, nearly 16 miles. This wasn't a minor incremental improvement. It represented a categorical advantage that turned tactical assumptions into death traps. Consider what this meant on the battlefield. A Wehrmacht battalion commander positioned his artillery 12,000 meters behind the front lines, believing his guns sat comfortably beyond American counter-battery range. American 105mm howitzers had an effective range of 11,000 meters. German commanders had encountered those weapons throughout 1943 and knew their limitations. The German 150mm SFH-18 howitzer, the backbone of Wehrmacht field artillery, reached 13,250 meters under optimal conditions. In practice, excessive barrel erosion limited most crews to 9,700 meters to preserve the guns. German artillery doctrine reflected these ranges. Position your guns 10 to 12 kilometers behind the lines, and you'd be safe from counter-battery fire while still able to support frontline troops. The Long Tom made that doctrine suicidal. American artillery observers, often pilots in light aircraft like the Piper L-4 Cub flying at 3,000 feet, would spot German gun flashes from positions 15 kilometers behind American lines. They'd radio coordinates to Long Tom batteries positioned even farther back, sometimes 18 kilometers from the front. The German guns would fire, thinking themselves safely beyond retaliation range. Then 100-pound American shells would start landing among them with devastating accuracy, fired from positions the German artillery couldn't even theoretically reach. It was the artillery equivalent of a boxer with a 7-foot reach fighting an opponent who could only extend 4 feet. The outcome was never in doubt, but range alone doesn't win artillery duels. Accuracy matters just as much. The Long Tom's legendary precision came from multiple factors that American artillery schools had spent decades perfecting. The gun itself featured a long L divided by 45 barrel, meaning the barrel length was 45 times the bore diameter. This extended barrel length provided longer acceleration time for the projectile, which translated to more consistent muzzle velocities and flatter trajectories at long range. The split-trail carriage design with its 8-wheel undercarriage created an exceptionally stable firing platform. Artillery pieces vibrate violently during firing. Those vibrations create inconsistencies in projectile flight. The Long Tom's massive carriage absorbed recoil forces that would have torn apart lighter carriages, maintaining aim even during sustained fire missions. Fire control represented another American advantage that Germans consistently underestimated. American forward observers used standardized procedures developed at Fort Sill, Oklahoma, the home of the U.S. Army Field Artillery School. Every adjustment, every correction followed proven mathematical formulas that accounted for wind, temperature, air density, and barrel wear. American artillery could deliver time on target fire, where multiple batteries synchronized their shots to arrive simultaneously on a single point, creating devastating concentration of firepower that overwhelmed German positions before defenders could react. German artillery operated under more rigid command structures, where battery commanders waited for corps-level orders before engaging targets. By the time German guns received firing coordinates, American shells were already landing. The ammunition supply chain completed the American artillery advantage. German forces, by 1944, faced chronic ammunition shortages, factories damaged by Allied bombing, transportation networks disrupted by air attacks, and raw material scarcity meant German gunners rationed shells carefully. An average German artillery battery might receive 30 rounds per gun per day. American batteries expected 300 rounds per gun per day as standard allocation, with the ability to request double that amount for critical fire missions. This 10-to-1 ammunition advantage meant American guns could fire probing rounds to establish accurate range, then deliver sustained bombardment that pulverized targets. German guns had to make every shell count, which meant less ranging fire, fewer corrections, and lower overall accuracy. The Long Tom's first combat deployment came on Christmas Eve 1942 in North Africa, when Battery A of the 36th Field Artillery Regiment fired supporting missions during American operations near Tebourba, Tunisia. The results exceeded expectations. German forces retreating toward defensive positions around the Kasserine Pass found themselves under accurate long-range fire from guns they couldn't locate and couldn't reach. Rommel's Afrika Korps had faced British artillery throughout the North African campaign, but nothing prepared them for the volume and accuracy of American heavy guns. German after-action reports from early 1943 contain repeated references to unexpectedly long-range American artillery fire, with intelligence officers struggling to explain how guns they identified as standard. 155mm weapons were hitting targets 3 to 4 kilometers beyond the range their manuals indicated was possible. By the time Allied forces invaded Sicily in July 1943, the Long Tom had become standard equipment for corps-level artillery battalions. Eventually, 49 battalions would operate Long Toms, with 40 battalions serving in the European theatre and 7 in the Pacific. Each battalion consisted of 12 guns organized into 3 batteries of 4 guns each. A typical corps in the European theatre controlled 3 to 4 Long Tom battalions, providing 48 guns capable of reaching any point within a 14-mile radius. For German commanders trying to position artillery, supply depots, command posts, or reserves in supposedly safe rear areas, this reach proved catastrophic. The gun's nickname requires explanation because it reveals how soldiers thought about the weapon. Long Tom wasn't an official designation. It emerged organically from gun crews who noticed the weapon's extraordinary barrel length and remarkable range. The term had history in American artillery tradition, dating back to Civil War-era naval guns, known for extended barrels. Soldiers in World War II adopted it naturally, the same way tankers called the M4 Sherman Ronson, because it supposedly lit on fire as reliably as a Ronson, lighter. Nicknames reveal truth. The Long Tom earned its name by doing exactly what the nickname implied. It reached farther than any gun had a right to reach, and it hit what it aimed at with the kind of precision that made defensive positions death traps. Production accelerated throughout 1943 as industrial capacity expanded. 3 guns built in 1940, 62 in 1941, 439 in 1942, 598 in 1943, 526 in 1944, 254 in 1945 before the war ended. Total production reached 1,882 M1A1 guns, not counting the original 20 M1 models. For comparison, Germany produced 6,756 of their SFH-18 howitzers throughout the entire war. The Americans built nearly 2,000 guns, with double the range in approximately half the time. The M1A1 designation appeared in 1941 after engineers modified the breech ring design to simplify manufacturing. The changes were minor, invisible to casual observation, but critical for mass production. The original M1 breech ring required a separate bushing insert where the breech mechanism threaded into the gun. The M1A1 cut the female threads directly into the breech ring itself, eliminating a component and reducing manufacturing time. In wartime production, every hour saved per gun translated to dozens of additional weapons delivered to the front. The M2 variant appeared in 1945 with further breech modifications, but by that point, the war was nearly over, and production numbers remained small. What made the Long Tom truly revolutionary wasn't just the gun itself, but the entire system surrounding it. Artillery effectiveness depends on coordination between multiple elements: the gun that fires the shell, the prime mover that positions the gun, the ammunition carriers that supply the shells, the forward observers who spot targets, the fire direction centers that calculate firing solutions, the radio networks that link everything together. American forces integrated all these elements into a synchronized system that treated artillery not as individual guns, but as a single, overwhelming force multiplied across dozens of batteries. The German Wehrmacht never developed comparable integration. German artillery battalions operated with greater autonomy, which sounds like flexibility but actually created problems. Different batteries used different equipment, followed different procedures, and answered to different command structures. A German corps commander wanting to mass fires on a critical target had to coordinate between units that might be using captured French guns, Czech guns, Polish guns, and German guns, all with different ranges, different ammunition, and different fire control procedures. It was organized chaos attempting to achieve precision, and it usually failed. American artillery doctrine emphasized simplification and standardization. Every gun crew learned the same procedures. Every forward observer used the same communication protocols. Every fire direction center calculated solutions using the same mathematical tables. This standardization meant a Long Tom battery transferred from 3rd Army to 1st Army could integrate into the new command structure within hours and deliver accurate fires immediately. Try transferring a German artillery battalion between army groups and watch the confusion multiply as different units struggled to coordinate across incompatible systems. June 6, 1944. The beaches of Normandy. While infantry struggled through surf and sand under machine gun fire, American artillery officers aboard command ships offshore were already calculating firing solutions for targets miles inland. The Long Tom batteries wouldn't arrive on French soil for several days, but their absence on D-Day itself revealed something critical about German defensive planning. The Wehrmacht had fortified the coast, expecting the invasion to be decided at the waterline. They'd built bunkers, planted obstacles, and positioned artillery to destroy landing craft and slaughter troops on beaches. What they hadn't adequately prepared for was what happened after the Allies broke through. The Long Toms were coming, and with them came the systematic destruction of every German position within 14 miles of wherever American forces chose to establish artillery positions. By June 10th, the first Long Tom batteries had been brought ashore and positioned in fields south of the beachheads. German forces retreating inland after the initial invasion assumed they were falling back to positions beyond Allied artillery range. This assumption lasted approximately 4 hours. Then, American shells started landing on German assembly areas, supply depots, and artillery positions that intelligence officers had assured commanders were safely beyond the range of standard field artillery. The Germans weren't wrong about standard field artillery. They were catastrophically wrong about the Long Tom. Consider the mathematics that German commanders faced. A standard defensive position in Normandy placed frontline infantry at the immediate contact line, battalion command posts 2 to 3 kilometers back, regimental headquarters 5 kilometers back, and divisional artillery 8 to 12 kilometers behind the front. This spacing represented decades of military doctrine based on the effective ranges of conventional artillery. Keep your guns close enough to support the infantry, far enough back to avoid counter-battery fire. The Long Tom made this doctrine obsolete overnight. American artillery observers flying over Normandy in light aircraft could see 20 miles in clear weather. They'd spot German positions 15 kilometers behind the lines and direct Long Tom fire onto them from batteries, positioned 18 kilometers from the front. The Germans found themselves under accurate artillery fire in areas their doctrine said were rear echelon safe zones. The psychological impact proved as devastating as the physical destruction. Wehrmacht soldiers had endured artillery bombardment throughout the war. They'd learned to recognize the sound of incoming shells, estimate trajectory from the whistle, and dive for cover in the seconds before impact. These were survival skills developed through brutal experience, but the Long Tom broke the pattern. Soldiers would hear the distinctive scream of incoming shells and instinctively look toward the front lines, expecting the fire to come from American positions a few kilometers away. Instead, the shells arrived from beyond the horizon, fired from guns positioned so far back that the sound of their firing never reached German lines. It created a disorienting reality where death arrived without warning from directions that doctrine said were impossible. Counter-battery fire, the standard response to enemy artillery, became an exercise in futility. German forward observers would spot American gun flashes and radio coordinates to their own artillery batteries. German gunners would calculate firing solutions and discover the American guns sat 2 to 3 kilometers beyond their maximum range. They could fire back, but their shells would fall short, wasting ammunition while the American batteries continued firing with impunity. It was the military equivalent of a knife fight, where one participant has arms twice as long as the other. Tactical skill becomes irrelevant when your opponent can strike you from positions you literally cannot reach. The battle for Caen in June and July 1944 demonstrated the Long Tom's capability to reshape battlefield geometry. German forces defending the city had positioned heavy artillery and Nebelwerfer rocket launchers in villages 8 to 10 kilometers south of Caen, safely beyond the range of standard Allied field artillery. These guns had been pounding British and Canadian forces, attacking the city with devastating effect. Allied commanders requested American Long Tom battalions to suppress the German artillery. Within 2 days, 4 Long Tom batteries had displaced to positions north of Caen and begun systematic counter-battery operations. German artillery positions that had operated with relative impunity suddenly found themselves under sustained bombardment from guns they couldn't locate and couldn't silence. Within a week, German artillery fire supporting the Caen defences had dropped by 70%, not because the guns were destroyed but because crews refused to fire, knowing that every shot revealed their position to American observers, who would direct immediate and overwhelming counter-battery fire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The rate of fire separated competent artillery from exceptional artillery. The Long Tom could sustain 40 rounds per hour indefinitely, with crews working in carefully choreographed sequences. 1 round per minute doesn't sound impressive until you multiply it by 12 guns per battalion and 4 battalions per corps. That's 48 shells landing on target every minute, 2,880 shells per hour, 69,120 shells per day if the ammunition supply held. German positions receiving this kind of sustained bombardment didn't just take casualties. They ceased to function as military units. Communications, trenches collapsed, bunkers caved in, ammunition depots exploded. Soldiers developed what contemporary medical officers called artillery neurosis, a psychological condition where men became incapable of functioning under sustained bombardment. The symptoms included trembling, inability to sleep, loss of appetite, and complete breakdown of unit cohesion. German units rotated out of the line after extended exposure to American artillery bombardment often required weeks of rest before they could return to combat effectiveness. The Germans tried to adapt. They moved artillery positions every 12 to 24 hours, displacing after firing missions to avoid counter-battery retaliation. This worked against conventional artillery with limited range. Against the Long Tom, it simply meant German guns spent more time moving and less time firing, while American batteries remained in prepared positions with ammunition stockpiles, surveyed firing data, and established communications. The Germans also tried massing their artillery to achieve local superiority, concentrating guns for brief, intense bombardments before dispersing. American fire direction centers responded by plotting German artillery concentrations and pre-registering Long Tom batteries on those coordinates. When German guns massed, American observers would spot them immediately and drop pre-calculated fire missions within minutes. The German guns would fire their brief bombardment and then try to displace, only to find American shells already landing among them. Bunker destruction revealed the Long Tom's brutal effectiveness against fortified positions. The Atlantic Wall, Hitler's vaunted coastal defense system, featured thousands of reinforced concrete bunkers with walls up to 3 meters thick. German engineers considered these bunkers proof against anything except sustained battleship bombardment or direct demolition charges placed by assault engineers. The Long Tom challenged that assumption. The M112 armor-piercing shell, specifically designed for fortification work, could penetrate 55 inches of reinforced concrete at 2-mile range. A standard German bunker with walls 36 inches thick offered no protection against repeated Long Tom strikes. American artillery tactics called for bunker shoots, where a single Long Tom would fire 50 to 70 rounds at a fortified position, methodically hammering the same point until the concrete shattered and the structure collapsed. The Siegfried Line, Germany's Western defensive fortification system, learned this lesson painfully in autumn 1944. The line stretched 630 kilometers from the Netherlands to Switzerland, featuring over 18,000 bunkers, pillboxes, and tunnel systems built throughout the late 1930s. German commanders considered it impregnable to anything except sustained siege operations that would cost the Allies months of casualties. American forces with Long Tom support breached the Siegfried Line in 6 weeks. The tactic was brutal in its simplicity. Artillery observers would identify bunker complexes. Long Tom batteries would establish firing positions 12 to 14 miles back, safely beyond German artillery range. Then the pounding would begin. 50 shells per bunker per day, day after day, until the concrete cracked, the walls collapsed, and defenders either died under falling rubble or abandoned the position. German after-action reports from September and October 1944 contain anguished references to Amerikanische Fernartillerie, American long-range artillery, destroying fortifications that were supposed to withstand months of bombardment. The Battle of Metz in October and November 1944 showcased Long Tom effectiveness against 19th-century fortresses that had been modernized with 20th-century concrete and steel. Metz, a fortress city on the Moselle River, featured a ring of forts built by the French in the 1870s and upgraded by the Germans after 1940. These weren't field fortifications. They were permanent defensive works with walls up to 4 meters thick, underground galleries, and interlocking fields of fire. German defenders believed Metz could withstand siege operations for 6 months. American commanders brought in 8 Long Tom battalions. The forts started falling within 3 weeks. Fort Driant, considered the strongest position in the Metz fortress system, received over 5,155 mm shells in 11 days. The bombardment pulverized concrete, collapsed tunnels, and broke the garrison's will to resist. When American infantry finally assaulted the fort on October 14th, they found dazed defenders who surrendered after token resistance. German prisoners interrogated after these battles provided remarkable insights into the psychological impact of American artillery superiority. A Wehrmacht Hauptmann captured near Aachen in October 1944 told his interrogators that his battalion had been reduced to 40% strength by American artillery before ever seeing American infantry. The shells came from positions his own artillery couldn't reach. His men called the Long Tom de lange Tod, the Long Death, because it killed from distances that made retaliation impossible. A Feldwebel from a panzer division captured in the Ardennes in December 1944 reported that his unit's greatest fear wasn't American tanks or aircraft, it was artillery. His company had lost more vehicles to artillery fire than to anti-tank weapons, and morale had collapsed because soldiers felt helpless against an enemy that could strike from beyond the horizon. Field Marshal Erwin Rommel, inspecting German defences in Normandy before D-Day, wrote in reports that were later captured and translated that the Allies possessed overwhelming superiority in artillery and outstandingly large supply of ammunition. He wasn't exaggerating. He was providing German High Command with accurate intelligence about the catastrophic mismatch between German and American artillery capabilities. His warnings were largely ignored. German strategic planning in 1944 still assumed rough parity in artillery effectiveness. This assumption cost them thousands of guns and tens of thousands of trained artillerymen who died trying to fight with weapons that couldn't reach American positions firing back at them. The crew operations of a Long Tom battery revealed the human element behind the statistics. Each gun required a crew of 15 men working in coordinated precision. The Chief of Section directed operations, calling out firing data received from the Fire Direction Center. The gunner operated the elevation and traverse mechanisms, adjusting aim according to fire commands. 2 ammunition handlers prepared shells and propellant charges, moving 95-pound projectiles from storage to the gun. The loader positioned shells into the breech, the rammer drove them home. The assistant gunner set fuses and closed the breech. The primer man inserted firing primers. The lanyard man pulled the firing lanyard on command. Behind them, ammunition bearers shuttled shells from the trucks to the gun position, an exhausting cycle of carrying 100-pound loads across muddy ground under all weather conditions. These crews operated in forward positions under constant threat of counter-battery fire, air attack, and occasionally direct ground assault. They worked through summer heat and winter cold, in rain that turned gun positions into quagmires and snow that froze mechanisms solid. They maintained sustained fire for hours during critical battles, handling shells until their hands bled through gloves. The physical toll was immense. A sustained fire mission involving 300 rounds meant each ammunition handler had lifted and moved over 28,000 pounds of shells and propellant charges. Do that for 6 hours, and you've performed the physical equivalent of lifting a loaded dump truck. Do it day after day, and you understand why artillery crews earned the grudging respect of infantry who watched them work. Accuracy life, the number of rounds a gun could fire before. Barrel wear degraded precision stood at 1,500 rounds for the Long Tom. That sounds like a limitation until you realize it represented over 400 days of sustained combat operations at normal firing rates. In practice, most Long Toms fired between 300 and 500 rounds before the war ended, well below the point where accuracy deteriorated. Barrels wore fastest when crews used supercharge ammunition frequently, as the additional propellant created higher pressures and temperatures that eroded the rifling. Battalion commanders carefully regulated supercharge use, authorizing it only for critical targets beyond standard range. Logistics determined artillery effectiveness as much as gunnery skill. Each Long Tom required approximately 3 tons of ammunition per day during active operations. Multiply that by 12 guns per battalion and 40 battalions in theatre, and you're looking at 1,400 tons of ammunition daily just for Long Tom operations. The United States industrial complex produced and shipped this ammunition without meaningful interruption throughout the war. By contrast, German artillery in late 1944 operated under severe ammunition rationing, sometimes limited to 10 rounds per gun per day. American gunners could fire probing shots to establish accurate range. German gunners had to make every shot count or face courts-martial for wasting scarce ammunition. The ammunition supply chain started at plants across America. DuPont manufactured the TNT explosive fill at facilities in Tennessee and Indiana. Steel mills in Pennsylvania produced the shell casings. Assembly plants in Illinois and Ohio loaded shells with explosives and fitted fuses. Everything moved by rail to ports, loaded onto Liberty ships, crossed the Atlantic, unloaded at French ports, and traveled by truck convoy to ammunition supply points near the front lines. From there, dedicated ammunition trucks shuttled shells to battalion dumps, where crews hand-loaded them onto the M21 or M23 ammunition trailers for final delivery to gun positions. This entire process, from factory to front line, operated with such efficiency that American artillery never faced ammunition shortages after the initial weeks following D-Day. The self-propelled variant, the M40 155mm gun motor carriage, mounted the Long Tom on a modified M4 Sherman tank chassis, entered production in January 1945. Only 418 were built before the war ended, but they demonstrated the future of heavy artillery. The M40 could travel at 25 miles per hour on roads, deploy in 8 minutes compared to 30 minutes for towed Long Toms, and reposition rapidly after firing to avoid counter-battery retaliation. In the few months they saw combat in 1945, M40s proved devastatingly effective during rapid advances where towed artillery couldn't keep pace with armoured spearheads. By January 1945, Wehrmacht artillery doctrine existed only as historical curiosity. Every assumption German officers had learned about artillery positioning, counter-battery operations, and defensive depth had been proven catastrophically wrong. The Long Tom hadn't just outperformed German artillery. It had rendered entire categories of German defensive thinking obsolete. Positions German commanders considered safely in the rear proved to be well within American artillery range. Counter-battery fire, the traditional response to enemy artillery, became impossible when your guns couldn't reach the enemy's positions. Even the psychological calculus of warfare had changed. German soldiers who'd learned to endure artillery bombardment through 3 years of Eastern Front combat found themselves psychologically broken by the sustained, accurate, long-range fire that American artillery delivered day after day without respite. The statistical evidence tells the story more brutally than any narrative could. During interrogations conducted in France between June and December 1944, German prisoners of war consistently reported that artillery caused 70 to 75% of casualties their units suffered. Not small arms fire, not tank encounters, not airstrikes. Artillery, American artillery specifically, delivered with volume and accuracy that German soldiers described as overwhelming. One interrogation report from September 1944, declassified decades after the war, contains a statement from a German Oberst commanding a Volksgrenadier division that perfectly captures the Wehrmacht's predicament. The American artillery fires 10 shells for every one we fire. Their guns outrange ours by 3 kilometers. Their ammunition supply is unlimited while we ration every round. How do they expect us to hold positions under these conditions? The answer, of course, was that German High Command didn't expect them to hold. They simply had no alternative. By late 1944, Germany's strategic situation had deteriorated to the point where defensive operations represented the only viable military option. But effective defense requires artillery superiority, or at minimum artillery parity. Germany had neither. The Long Tom and the broader American artillery system had created a situation where German forces defended positions under constant bombardment from guns they couldn't silence, supplied by an industrial base they couldn't disrupt, directed by observers they couldn't shoot down. It was a formula for systematic destruction, and that's exactly what happened. The Rhine River crossings in March 1945 demonstrated American artillery dominance in its most concentrated form. German forces defending the west bank of the Rhine had spent months fortifying positions, constructing bunkers, planting obstacles, and pre-registering artillery on every likely crossing point. They believed the Rhine represented a natural defensive barrier that would cost the Allies weeks of casualties to breach. American forces approached the river with over 300 artillery battalions, including 32 Long Tom battalions positioned in carefully surveyed positions. The preparatory bombardment before the Rhine crossings represented the single greatest concentration of artillery firepower in the European theatre. Long-tom batteries fired over 20,000 shells in the first 24 hours, systematically destroying German bunkers, suppressing artillery, and pulverizing defensive positions across a 50-mile front. When American and British forces crossed on March 23rd and 24th, they encountered disorganized resistance from shell-shocked defenders who'd endured 48 hours of sustained bombardment. German artillery, which should have massacred troops crossing the river, fired sporadically and ineffectively. American counter-battery operations had either destroyed the guns or forced crews to abandon positions. The Rhine crossings, which German propaganda had promised would become a Stalingrad in the west, turned into a logistics exercise. The artillery had already won the battle before infantry ever set foot in assault boats. The cost in German lives and equipment defied easy calculation. By March 1945, Wehrmacht artillery losses on the Western Front exceeded 70% of available guns. Not all destroyed by counter-battery fire, though thousands were. Many were abandoned when crews lacked the fuel or vehicles to withdraw them during rapid retreats. Others were captured intact when American forces overran positions before defenders could spike the guns. But the primary killer remained counter-battery fire from weapons like the long-tom that German gunners couldn't answer. A German artillery battery commander captured near Remagen in March 1945, when asked during interrogation why his unit had abandoned 15 guns, in working condition, responded with weary resignation. What was the point? Every time we fired, American shells landed among us within 2 minutes. We couldn't move fast enough to avoid them. We couldn't shoot back because our guns didn't have the range. Better to abandon the guns and save the men. That statement encapsulated the psychological collapse of German artillery operations in the war's final months. The Wehrmacht had begun the war with confidence in their artillery arm, built through rearmament programs in the 1930s and validated by victories in Poland, France, and the Soviet Union. By 1945, German artillerymen knew they were outgunned, outranged, and overwhelmed by opponents who possessed every advantage. The long-tom represented just one weapon in the American artillery arsenal, but it symbolized the broader technological and industrial superiority that made German defeat inevitable. The Pacific theater saw different but equally devastating applications of long-tom firepower. 7 long-tom battalions deployed to the Pacific, where they faced Japanese defensive positions even more heavily fortified than German bunkers in Europe. The Japanese doctrine of defense in depth, utilizing cave systems, tunnels, and reinforced concrete pillboxes, seemed purpose-built to resist conventional artillery. The long-tom proved otherwise. On Peleliu in September 1944, long-tom batteries systematically destroyed Japanese cave positions by firing hundreds of shells at cave entrances, collapsing tunnels and burying defenders alive. On Okinawa in April 1945, long-toms provided fire support for the assault on the Shuri line, Japanese defensive positions considered impregnable. The guns fired over 60,000 shells during the Okinawa campaign, more ammunition expended than in any other Pacific battle. Japanese defensive positions that should have required weeks of costly infantry assaults fell to artillery, a bombardment that turned fortifications into rubble. The war ended in May 1945 in Europe and August 1945 in the Pacific. But the long-tom's service continued for decades. The gun that had revolutionized artillery warfare in World War II proved equally valuable in subsequent conflicts. Korea saw extensive long-tom operations from 1950 to 1953, where the gun's long range proved ideal for providing fire support across the peninsula's mountainous terrain. Vietnam employed long-toms for fire-based defense and interdiction fires until the early 1970s. Foreign militaries continued operating long-toms even longer. The Israeli Defense Forces used them in the 1967 Six-Day War and the 1973 Yom Kippur War. The Dominican Republic operated long-toms until 1984, 44 years after the prototype first fired. That longevity testified to fundamental soundness in the design. The long-tom did exactly what it was supposed to do, and it did it well enough that militaries continued using it long after more modern weapons became available. The technical legacy extended beyond the weapon itself into artillery doctrine that shaped American military thinking for generations. The long tom demonstrated that range and accuracy multiplied firepower more effectively than sheer volume. A single accurate shell landing on target accomplished more than a dozen inaccurate shells, scattering across a grid square. This lesson influenced artillery development throughout the Cold War, where American artillery emphasized precision and range, while Soviet artillery emphasized massed fires. The M107 175mm gun that entered service in the 1960s represented direct doctrinal descendant of the long tom, offering even greater range with similar accuracy. Modern artillery systems like the M109 Paladin and the M777 howitzer still reflect design philosophies developed during long tom operations. Position the guns safely beyond enemy counter-battery range. Deliver accurate fires on targets the enemy can't defend. Maintain sustained operations through reliable ammunition supply. These principles, proven by the long tom in World War II, remain fundamental to American artillery doctrine in the 21st century. The human cost of the artillery revolution deserves acknowledgement. American long tom battalions lost approximately 400 men killed during World War II operations, with another 1,000 wounded. Most casualties came not from counter-battery fire, though German artillery occasionally achieved devastating hits, but from air attacks and accidents during operations. Artillery work remained dangerous under any circumstances. Shells, weighing 100 pounds, moving at high velocity, don't forgive mistakes. Propellant bags occasionally ignited prematurely. Defective shells exploded in barrels. Exhausted crews made errors that killed themselves and their comrades. Every long tom battery left men in graves scattered across North Africa, Italy, France, and Germany, casualties of a war fought not just with courage, but with the brutal mathematics of industrial firepower. German casualties from American artillery numbered in the hundreds of thousands, though exact figures remain impossible to calculate. Medical reports from Wehrmacht units in late 1944 consistently show that 70 to 75% of casualties resulted from artillery fire. Apply that percentage to total German casualties on the Western Front, and you're looking at 200,000 to 300,000 men killed or wounded by American artillery. The long tom didn't account for all those casualties, but it represented a significant portion, particularly among artillery crews, command posts, and fortified positions where conventional artillery proved ineffective. Every bunker collapsed by armor-piercing shells. Every artillery battery destroyed by counter-battery fire, every command post obliterated by time-on-target missions added to a casualty count that broke the Wehrmacht's ability to defend. The industrial achievement behind long tom production matched the weapon's battlefield success. Building nearly 2,000 heavy artillery pieces, while simultaneously producing tanks, aircraft, ships, and every other implement of modern warfare demonstrated industrial capacity that Germany and Japan couldn't begin to match. The United States in 1944 operated multiple arsenals capable of producing heavy artillery, employed hundreds of thousands of workers in ordnance plants, and maintained quality control standards that ensured weapons worked reliably under combat conditions. German industry by 1944 relied increasingly on slave labor, suffered chronic raw material shortages, and faced constant disruption from Allied bombing. The long tom rolled off American production lines at the rate of 50 guns per month during peak production. Germany struggled to produce artillery at all. The story of the long tom ultimately reveals a fundamental truth about modern warfare that many military establishments resist acknowledging. Victory belongs not to the army with the bravest soldiers or the most brilliant generals, though those factors matter. Victory belongs to the side that can deliver more firepower more accurately over longer periods than the enemy can withstand. The Wehrmacht in 1939 believed that tactical brilliance and operational excellence could overcome material disadvantages. By 1945, German commanders understood that no amount of tactical skill could compensate for artillery that couldn't reach enemy guns, industries that couldn't produce sufficient ammunition, and logistics networks that couldn't deliver supplies to frontline units. American artillery, epitomized by the long tom, but extending across the entire artillery branch, proved that industrial capacity converted directly into battlefield dominance. The 155mm shells landing on German positions represented more than explosive power. They represented an industrial base that could produce millions of shells, a transportation network that could deliver them to Europe, a logistics system that could distribute them to frontline units, and a training program that created thousands of skilled artillerymen who could employ them effectively. Germany possessed none of these advantages by 1944, and tactical brilliance couldn't compensate for their absence. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The Long Tom stands now in museums and military parks, preserved as historical artifacts from a war that ended 80 years ago. 3 survive in operational condition. The SS John W. Brown Liberty Ship Museum in Baltimore maintains a Long Tom on display. Fort Sill, Oklahoma, the home of American field artillery, preserves multiple examples. The Georgia Veterans State Park displays a Long Tom manufactured in 1943, still imposing despite decades of weathering. These museum pieces represent more than old artillery. They embody the moment when warfare transformed from tactical art into industrial science, when victory became less about courage and more about production capacity, when range and accuracy replaced massed fire as artillery's defining characteristics. The Wehrmacht never expected 155mm Long Toms to obliterate bunkers from 14 miles away because their doctrine, their training, and their experience all said such weapons didn't exist. German artillery officers in 1939 had learned from the best artillery traditions in Europe, studied in schools that taught lessons proven by centuries of warfare, and commanded guns that represented the pinnacle of artillery development. Everything they knew was correct, right up until the moment American shells started landing among them from positions their guns couldn't reach. Then their knowledge became obsolete, their training became inadequate, and their experience became meaningless. The Long Tom didn't just outrange German artillery, it rendered German artillery doctrine obsolete, German defensive positions untenable, and German artillery crews helpless against an enemy that struck from beyond the horizon with accuracy that made every shot count. That lesson, written in the rubble of destroyed bunkers and the graves of artillery crews who died trying to fight with inadequate weapons, it remains relevant wherever militaries face opponents with superior range and firepower. Technology advantages compound over time. The side that can reach farther, hit harder, and sustain fire longer doesn't just win artillery duels, it wins wars. The Long Tom proved that principle across 2 years of combat in Europe and the Pacific, demonstrating that industrial capacity and technological superiority trump tactical brilliance when the gap becomes wide enough. German commanders learned that lesson at terrible cost, watching their artillery torn apart by weapons they couldn't answer and defences shattered by bombardment they couldn't prevent. The price of that education was paid in German blood, German steel, and the collapse of every defensive line Germany tried to hold against American forces, advancing behind a wall of artillery fire that swept everything before it. The 155mm gun M1, the Long Tom, earned its nickname not through battlefield mythology, but through demonstrated performance that exceeded every specification the Westerwelt board had demanded in 1919. It fired farther than any comparable weapon. It hit with accuracy that turned long-range fire from harassment into precision destruction. It served in every theatre where American forces fought, from North African deserts to Pacific islands to European forests, proving equally effective against every enemy and terrain. Most importantly, it created a new standard for what artillery could accomplish, demonstrating that range and precision multiplied by industrial production capacity generated combat power that tactical brilliance couldn't overcome. That legacy outlived the gun itself, shaping artillery development for 3 generations, and proving that sometimes the most revolutionary weapons are the ones that do exactly what they promise, just better than anyone expected possible. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.